Here we go, double angle and half angle formulas. All right, so in this problem, we have two pictures. I want you to use the givens to evaluate each function. So we have f of 2 theta, g of half theta, and then h of 2 theta. All right, for f, g, and h, I have a different function for you. So first, let's analyze the two circles. All right, so let's do the first one. The first one, I like that one. Why? Because that makes you to review something you learned in the past. Remember this, you have x squared minus, it's not x squared, you have x minus h squared plus y minus k squared equals to r squared. What is this? This is equation of a circle where the center is hk and then the radius is r. But there is an x squared plus y squared only. I don't see a h and a k. Well, here is the h and k, so you have x minus 0 square plus y minus 0 square. What about the phi? The phi is not in square, right? Square root of phi square. How's that? So where is the center? The center is 0, 0 is there, right? 0, 0, and then the radius is square root of phi. So the radius is square root of phi. That means the length of the blue segment, again, the length of the blue segment is square root of 5. All right, we have A and a 2. We don't know what A is. But I know that that segment is in quadrant 2. So here is how we are going to do it. We are going to draw a triangle right here. So we are going to have this right triangle. This is a 90 degree. Let's don't name the angle. This is in quadrant 2. So A, what is the x? We don't know what it is. So A, the y is equals to 2. The hypotenuse is equals to 5. We use Pythagorean theorem to find A. So we have a squared plus 2 squared equals to root 5. So that is a squared, forgot the square, 5 minus 4 equals to 1, right? 5 minus 4 equals to 1. Is A equals to 1 after the square root? Nope, the answer is not true because A is x, right? So in quadrant 2, we have negative x and positive y. So A is equals to negative 1 in quadrant 2. So the point is, what is the point? The point at quadrant 2 is negative 1 comma 2. So that is the how we analyze the circle. Let's analyze the other circle as well, but before we do that, let me tell you, look at the problem. They are all theta, right? They didn't ask for alpha. I make another picture for you because what if the segment or the point is in another quadrant, right? So I make another circle for you. So let's switch color for that circle. Okay, so in quadrant 3, this is in quadrant 3, we are going to make a triangle right there. So in quadrant 3, we have this triangle in quadrant 3. All right, what is the radius of the circle? So the radius is x minus 0 square plus y minus 0 square equals to 1. So you have the center is at 0, 0. The radius is 1 square, right? This is equals to 1. So that means the radius of this segment is equals to 1. And then the x coordinate is negative 1/4. So this is negative 1/4. And then the length of this is b. So, but be careful. B, in quadrant 3, both x and y are negative. So in quadrant 3, we have negative x and negative y. Let's use Pythagorean. We have negative 1/4 square plus b square equals to 1. So b square is equals to 1 minus 1/16. That is 15/16. You take the square root of that. So b is equals to the square root of 15/16. So that is the square root of 15 divided by 4. Is this done? No, not done. Because in quadrant 2, y is negative. So b is equals to negative root 15 divided by 4 in quadrant 2. So the x and y coordinate, what do we have? We have negative 1/4, quadrant 2, Roman numeral. negative 15 over 4. So that is how you analyze the second circle. But we don't really need the second circle because none of the problem is asking for alpha. Okay, let's do the first problem. The first problem, what do we have? We have sine of theta. So do you still remember your composition function? So number one, we have f of x equals to sine x, and then I have f of 2 theta. What does that mean? That means you replace the x with 2 theta. So here is how we do it. It was supposed to be sine x, right? But you replace the x with 2 theta. So you pick up your eraser, you erase the x, and then replace that with a 2 theta. After that, you apply the double angle formula. So that is sine 2 times sine theta cosine theta. And then you plug in. So sine, what is sine? Sine theta. So speaking of sine theta, we have to use the right triangle. So right triangle, let's draw another one right here. So we have this, we have 2, a is equals to negative 1, and then b is equals to root 5, right? Did I copy everything right? This is in quadrant 2. Yep. And then going back to the triangle for the first problem, we have sine of theta that equals, we have a right triangle. Because we are going to work with the sine, cosine, and tangent, we have to figure out the sine theta, cosine theta, and tangent theta. Okay, so for the sine theta, we have opposites. We have the SOHCAHTOA, so opposite divided by hypotenuse. So we have 2 divided by root 5, and then you rationalize that, multiply the top and bottom by root 5. You have 2 root 5 divided by 5. CAH, so that is a negative 1 divided by root 5. So multiply the top and bottom by square root of 5. You have negative root 5 divided by 5. And then tangent is TOA, opposite, divided by adjacent. So that is a negative 2. And then we use this to answer the question. So the first one is f of x equals to sine of x. So and then you have f of 2 theta. So it was sine of x, right? You replace the x with 2 theta. So you go ahead, erase the x, and then you put a 2 theta in there, and then you apply the formula. So that is 2 times sine theta cosine theta. So you have 2 times 2 root 5 divided by 5, and then a negative 5 divided by 5, so multiply all of this, you have negative 4 over 5. So that is the answer to the first one. And then the next one, you have a half angle for the cosine. So let's go back to if you go back to the problem, where is the triangle? The location of the triangle is in quadrant 2, right? So in quadrant 2, using radian, what is the theta between? The theta is between what? The theta is between pi over 2 and pi, right? So this is any angle between 90 degree and 180 degree. So if you divide it by 2, so that will be a pi divided by 2. So this divided by 2, then that will be a pi over 4. So this will be in quadrant 1. So in quadrant 1, we have both x and y are positive. So when you consider the plus or minus, you take the plus. So the g of x equals to cosine x, and then we have g of theta divided by 2. So that is cosine theta divided by 2, and then you take the plus, because in quadrant 1, x is positive. You have 1 plus cosine of theta divided by 2, and then you plug in the cosine. The cosine is right there. So that is 1 plus negative root 5 divided by 5 over 2. And then you have 5. This is a 5 minus root 5 divided by 2. So you have a 10 in here. So you have a 5 minus root 5 divided by 10. And then here is one little technique. Multiply the top and bottom by 10. So that gives me 100 in the denominator. So you have 10 times 5 minus root 5 divided by 100, right? So once you take the square root in the denominator, that is equals to 10. So we don't have any more square root in the denominator. So that is your cosine, half theta, and then the last one is you have h of x equals to tangent x, and then h of 2 theta is equals to tangent theta, tangent 2 theta, that is 2 times tangent theta divided by 1 minus tangent square of theta. You plug in the theta. Where is the tangent? The tangent is right here. You plug in the negative 2. So this is 2 times negative 2, and then 1 minus negative 2 square. So you have negative 4 divided by negative 3. So that is 4 over 3. So that is the end of this problem. I will see you all in the next lesson.